One of the most important topic from where they frequently ask question is cantilever bracket. So suppose you are given with a cantilever bracket like this ABC, as you can see in the figure, with load P acting at the point C, and you need to determine the bending moment and twisting moment for the members. So how to do it? Hello everyone, welcome you all to this video session conducted by EduPortal, and in today's video I will be talking about the interview preparation strategies along with question and answer for recruitment of assistant engineer civil in various state public service commission examinations like West Bengal PSC, Uttar Pradesh PSC, Assam PSC and other state PSCs also. So let's get started. So this is part number 1 of our video series, and here we will discuss about the civil engineering interview question and answer, only the technical portions. Okay, so all the questions that we are going to discuss in this video are based on the past interview experience of our successful team members, previous experience of other qualified candidates, tips from our respected teachers and seniors, and suggestions from technical officers. Okay, now let me tell you how we had collected these questions. Okay, so for that we had done surveys where we had asked the previously qualified candidates regarding their interview experience, and from there we had collected the questions, and then we had several number of meetings where our teachers and senior technical officers shared their valuable suggestions for interview preparation strategies, and then we had sorted out the most important questions which have been asked most frequently in the examinations, and based upon these questions we had made this video. Okay, now what are the things that we are going to cover in this video? Okay, so first of all, interview questions and answers, and along with that I'm also going to tell you what the interviewer exactly thinks when he is asking some questions and what answer he is expecting from the students. Okay, and then what are the mistakes that students generally do in the interview, and then some interview preparation strategies and tips. Okay, so before starting the question answer series, let me tell you the weightage of the questions. Okay, so it has been found by analysis that 50% of the questions are asked from structural analysis, solid mechanics, RCC and steel design and specifications, highway engineering, building material and constructions, soil mechanics and foundation, and irrigation engineering. So, okay, so 50% are percentage of the questions are asked from these portions. Okay, and then 30% of the questions are asked from BTech project, organizations work profile. Okay, so you need to know what kind of work that organizations do. Okay, then work experience, if you have any work experience then they will ask about it. Then MTech project, if you have MTech project then they will ask about it. Area of your interest. Okay, so sometimes they ask you to tell 2 or 3 area of your interest so that they can ask questions from there. Okay, and then famous structures nearby and its technical knowledge. Okay, so you need to know if some famous structures is nearby you, and you should know what are the technical specifications of it. Okay, so sometimes they ask these questions. Okay, and it gives extra advantage if you tell it correctly. Okay, and 20% of the questions are asked from hydrology, fluid mechanics, environmental engineering, survey and geology, construction management, transportation engineering, engineering mechanics. Okay, now this environmental engineering, if you are going to appear for the interview of municipal service commission examinations, then from environmental engineering they ask a lot of questions, especially from water supply portions. Okay, so this is the general distribution of questions. It may vary, but based upon the interview experience of successfully qualified candidates, we had found that the weightage of the questions are like this. Okay, now let's move into the question answer portion. So let's get started. So first of all, let's start with the structural analysis portion, and the most common question they ask from this portion is shear force and bending moment diagram of portal frame. Okay, So suppose portal frame is given like this, you need to draw the bending moment diagram of the portal frame. Okay, so UDL is given, so don't directly draw this portal frame. Okay, so first show the arrow diagram, that is UDL is given, so here will be hawking bending moment and hawking bending moment. Okay, so after that, after analysis of this joint, the moment here will be like this and here will be like this. Okay, now because end A is fixed, end E is fixed, so carryover factor is 0.5, so half the moment will be transferred here and half the moment will be transferred here. Okay, so after drawing this arrow diagram, draw the bending moment diagram and it will be good. Okay, then and next is suppose portal frame is given like this and P is the lateral load is given like this. Okay, so for that here the loading bending moment will be like this and bending moment will be like this here. Okay, now after analysis of joint B, the loading will be here like this and here the loading will be like this. Okay, so because end A is hinged and D is hinged, so no moment will be transferred there, so M equal to 0, right? M is equal to 0 here, M is equal to 0 here, and after that draw this bending moment diagram. Okay, then next, suppose this kind of loading is given on the portal frame, that is point load on the member BD. So here the same bending moment will be there and there, there, and here it is fixed, so half the moment will be transferred here. And after drawing this arrow diagram, draw this bending moment diagram. Okay, so these three are the basic, so they may not give you the basic portal frame, they may give you the combination of concentrated load P plus UDL, or concentrated load P plus lateral load P, or lateral load P plus UDL. Okay, so they can give you the combination of loading and you need to draw the bending moment diagram. Okay, so the thing that they check is whether you know how to draw the bending moment diagram, how to draw, whether you know or not. And second thing they check whether you know this pattern or not. That is for point load, the bending moment diagram will be linear. Okay, linear, that is degree 1 degree, and for lateral load here it is also 1 degree, and for UDL it is second degree curve. So they want to check whether you know the pattern of bending moment diagram or not. Okay, so this is the bending moment diagram of portal frame. So to solve the questions in the interview, you need to have clear concept of the portal frame and bending moment, then do a lot of practice and then go for the interview. Okay, now let's move on to the next topic. The next topic is bending moment, torque, shear and axial force of cantilever bracket. Okay, this cantilever bracket is very important. Okay, in almost all the interview they ask a question from cantilever bracket. Now what kind of questions they ask? Okay, so suppose a cantilever bracket is given like this, ABC, with load P at the end C, and you need to draw the bending moment diagram, or you need to determine the bending moment or twisting moment in the members. Okay, so how to do it? Now those who have already solved these kind of questions, you know that the member BC, in the member BC there will be varying bending moment, and maximum bending moment BM max will be at the point B, and its value will be P into E. Okay, P into E. Now, for the analysis of the member AB, we need to transfer this load from point C to point B. Okay, now if we transfer this load, so for the member AB, there will be a load P at this point, and along with that, another load, that is T, and it is the torque, which is equal to P into E. So the bending moment for the member CB acts as the torque for the member AB. Okay, so for the load P, there will be varying bending moment in the member AB, and the maximum value of bending moment BM maximum equal to P into L, and it occurs at the point A. Okay, so for the member CV, maximum bending moment occurs at point B, and for the member BA, maximum bending moment occurs at point A. Okay, so for member BC, bending moment is P into X. Okay, any distance X, this is X. Okay, so any distance X from here, and no twisting moment for the member BC. But for the member BA, twisting moment, what is the value? Its value is P into E, and what is the value of bending moment? P into Y. Okay, so Y is this distance. Okay, so you can see Y. So now this is the solution. Now let's solve this problem in detail by taking one member at a time. Okay, so here you can see this is the load. Okay, this is the load P. So E is the eccentricity. So here it will be, there will be a torque. Okay, so torque, here will be a torque, value of the torque T equal to P into E. Okay, so its value is clockwise. Okay, you can see clockwise. So for the member, for this member, there will be a load P and a torque T is equal to P into E. Okay, so for there is A, B, C. So, okay, so for AB member, the bending moment equal to P into Y, and torque is equal to P into E. Okay. Now for BC member, bending moment equal to P into X and torque equal to 0. Okay. So this is X direction and this is Y direction. Okay, so this is the solution of this problem. So they can give you different types of problem like this. So here the solution will be same. So because of this, there will be a torque for this QR. So bending moment for this member PQ will act as the torque for the member RQ. So everything is same. So you need to solve this kind of problem a lot to solve these questions in the examinations. Okay, so I am not going in detail. Okay, so suppose a loading is a load is given like this. So for the member AB, suppose this is BA, a load W is acting here. Okay, so for here there will be a Hawking bending moment. Okay, Hawking bending moments. Okay, here, and for this there will be a for if y equal to 0 for the member PA. So here W will be like this and here W will be like this. Okay, so W will be like this. Okay, so this is member BA, this is member BC. Okay, so there will be the axial force. Axial force, what is the value of axial force? Value of axial force equal to W, and axial force is in the member BC. And for the member BA, there will be, for the member BA, this is the BMD, bending moment diagram, and its value, suppose it is A, so W into A. Okay, so there will be axial force in the member BC, and there will be this is anti-clockwise, so there will be clockwise. Okay, so this, okay, so there will be bending moment also, bending moment also plus axial force in the member BC, and in the member BA there will be shear force plus bending moment. Okay, so these are the type of questions. Or let's take another questions like this. So here a load is given like this. Suppose this is A, this is B, this is C, this is D, this is A distance, and this is 2A. Okay, so this is A. So the same, there will be a, this is BMD, so and its value is equal to P into 2A. Okay, so you need to draw the bending moment diagram, or you need to, and this load for, so for this member BC, for this member BC, this P load act as the axial force. Okay, so these kind of questions they ask in the examinations. Okay, now I am not going in detailed solution, because all the solutions of this kind of questions I will share in our video course, that is concept through MCQ video course. Okay, so here I am telling just the type of question they can ask in the interview and how to approach for this kind of questions. Okay, now let's move to the next topic. Now we will move to the solid mechanics section, where they will ask questions from properties of material, stress strain curve of ductile and brittle material, etc. Okay, so you will be asked to draw the stress strain curve of mild steel. So you need to draw this curve and you need to mention all the points, that is A, proportional limit point, B is the elastic limit, C is the upper yield point, D is the lower yield point, E is the ultimate stress point, and F is the breaking point or fracture point. Okay, and also the question that why lower yield point is taken for the analysis, and what is the difference between proportional limit and elastic limit. Okay, and what is the significance of this elastic limit region, and what is this proportional limit region. This kind of questions they can ask. Okay, so you can also draw this curve to show the different types of region, like linear region up to the proportional limit, up to which Hooke's law is valid, and then perfect plasticity or yielding region, then strain hardening region, and then necking region. Okay, so they sometimes ask the question that where necking occurs, in which region, that is between the ultimate stress point and the fracture point. Okay, so this is the engineering stress strain curve, and this is true stress strain curve. Okay, so and then they will ask you to show the stress strain curve of ductile material and brittle material in the same stress strain graph. Okay, so you need to draw this kind of curve. Okay, and this is the failure of brittle material, that is 90-degree failure. This is the failure of ductile material, that is necking failure. And then they will ask you how to determine the yield point for brittle material, because they have no specific yield point. Okay, then how to find its yield point. So for that you need to draw this and show that at 0.2% of the strain, that is 0.002 strain, 0.002 strain, we need to draw a straight line which is parallel to the initial stress strain curve, initial stress strain curve, that is the linear portion. So we need to draw a line parallel to this, and at the point at which this line intersects the curve is the proof stress. Okay, so this point is taken as a yield point for brittle material. Okay, so these are the common questions they ask from the stress strain curve. Now next they can ask you to show the failure pattern of ductile and brittle material under tension. Okay, so suppose the tensile force is T for ductile and brittle material. Okay, so in ductile material necking phenomena can be seen. Okay, so this is failure pattern of ductile material, and this is the failure pattern of the brittle material, and the failure surface makes an angle 90-degree with the axis of the member. Okay, so this is the failure surface. Okay, this is failure surface of brittle material. This is under tension. Okay, so this is under tension, and it is a failure pattern. You may have to show the failure pattern. And next is they can ask you to show the failure pattern of ductile and brittle material under torsion. Okay, so suppose it is the material and it is under torsion. Okay, under torsion, T is the torque. So in case of ductile material, the failure surface makes an angle 90-degree with the axis of the member. So under torsion, ductile material, in case of ductile material, the failure surface makes an angle 90-degree with the axis. Okay, under torsion, in case of brittle material, the failure surface makes an angle 45-degree with the axis of the member. Okay, so this is the main difference. So in case of ductile and brittle material under tension, ductile material necking phenomena can be seen in ductile material and brittle material, and in case of brittle material, failure surface is 90-degree, but in case of torsion, the failure surface of ductile material is 90-degree, and in case of brittle material, the failure surface makes an angle 45-degree with the axis of the member. Okay, so this is the axis of the member. So these are the main two types of failure of ductile and brittle material. Okay, so these are the questions that can be asked in the interview. A lot of questions actually can be asked. Okay, so you need to study this chapter very carefully. This is very important chapter. Okay, now let's move to the next topic. Now let's come to the structural analysis portion again, and here we will discuss about the earthquake resistance building construction, and that is the ductile detailing. Okay, so in recent years it has been found that a lot of questions are been asked from ductile detailing. Okay, so you need to study this portion before going to an interview. Okay, so first what they will ask is about the code, that is ductile detail code for ductile detailing, that is IS 13920 and it is the ductile detailing of reinforced concrete structure subjected to seismic forces. Okay, so name of the code is the first thing they ask about the ductile detailing, and then the question comes is about the seismic zones. How many seismic zones are there? So 4 zones. So you need to tell this, and just study the name of the 4 zones. Okay, and then and the code is 1893 part 1, and then the question comes is where do you live and under which zone it falls. Okay, so just make sure that where you live, the in that location under seismic zone, under which seismic zone, it falls. Okay, so make sure you know this answer. Okay, so it gives you extra advantage. Okay, now then they will ask you to say some points about ductile detailing. Okay, so for that the code is IS 13920. Okay, so here a lot of things are there in ductile detailing. Oh, okay, so I will tell you the 4 important points that you must mention in the ductile detailing. Okay, so first one is this hook, 135-degree hook, 135-degree hook. Okay, so why it is provided? The ends of the stirrups are bent at 135 degree. Such stirrups do not open during the strong earthquake shaking. Okay, so this 135 hook is provided so that they do not open during the earthquake shaking. Okay, so this is very important. Number one, this is number one specification, and second one is the specification for vertical stirrup. Okay, so what will be the spacing of vertical stirrups? Okay, so you can also find it in 13920, and I'm not going in detail about the specification because you will find everything in 13920. I'm just telling you what to study. Okay, and then comes so this is number two. So number two, that is vertical spacing, and number three comes is the lapping. So lapping specification, and you can also find it in 13920. Okay, so lapping of longitudinal bars. Okay, so you must study this from IS 9 through to IS 13920, and then the thing that comes is anchorage of beam bars in beam column joint. Okay, so beam column joint, this is very important, from very important, and you need to know the specification, and you need to know the specifications there, and you study it from IS 13920. Okay, IS 13920. Okay, so these are the 4 important things. So first one is a 135-degree hook. Okay, and the second one is vertical stirrup, vertical stirrup spacing. Okay, and the third one is lapping specification, lapping specification, and the fourth one is beam column joint. Okay, beam column joint. Okay, so before going to the interview, make sure that you have studied these 4 points. Okay, so if they ask you to say something about the ductile detailing, you must say these 4 points. Okay, so these are very important. Go through the IS 13920 and make a note of these 4 points. Okay, now let's move to our next topic. Uh, and our next topic is arch and cable, its advantage and behavior under loading. Okay, so under loading, so it is again from structural analysis, and so the first question that comes is what are the advantages of arch over beam. Okay, so it is a very common question, and I hope you know the answer, that is for the same loading and same span, bending moment of arch is smaller than bending moment of beam. Bending moment of arch is less than bending moment of beam. Okay, so because the bending moment in arch is small, so section required in arch is less than section required in beam. Okay, so using arch will be economical. Okay, so thinner cross section will be required for arch. Okay, so now they will tell you to prove this, why the bending moment of arch is less. So for that, just take a simply supported beam like this of span L, and a load P is acting at the midpoint. So VA, that is vertical reaction at support A, equal to P by 2 and VB equal to P by 2. Then take a point D at a distance X from the support left support, that is support A. So bending moment, that is mx at D equal to VA into X. So VA into this distance X equal to bending moment at point D. Okay, now this is all about the simply supported beam. Now take a arch. Okay, take an arch, its span is same like the beam, that is L. Okay, so P is acting at the midpoint of the span. So loading, so vertical reaction at support A, VA equal to P by 2 and VB equal to P by 2. And now P by 2, P by 2. Now take another point D, that is X from the left support, just like what we have done in case of simply supported beam, that is we have taken a point D, that is distance X from the left support, and in case of arch we are doing the same, taking a point D, that is at the distance X from the left support. So everything is same, load position and span, everything is same. So difference is one is beam and one is arch. So here mx equal to bending moment at D, and it is equal to VA into X minus HA into Y. So VA into X minus HA, that is the horizontal reaction, into Y. Okay, so this is the difference. Okay, so you can see here bending moment of arch equal to bending moment of beam minus HA into Y. Okay, so you can say that bending moment of arch is less than bending moment of Y. Okay, so why? Because of this height Y. So even if you take the horizontal reaction for simply supported beam, even if it is there, so but there is no Y, so H into 0. Okay, so here the bending moment is VA into X, here the bending moment is V into X minus H into Y. That's why bending moment of arch is less than bending moment of beam. Okay, and bending moment of beam. And what is the advantage? Because bending moment is less, so section required is less, so thinner section will be required for arch section. Okay, that's why using arch is economical. So that is the advantage of using arch over beam. Okay, so this is one question, and they can then they can ask you to solve this kind of numerical, easy numerical, and this is just to check whether you have studied this chapter in your course and whether you know how to solve it. Okay, so to solve it, you just check this. I hope you have solved this earlier. So for this, first take a moment about point B equal to 0. So doing this, you get the vertical reaction VA is equal to 7.5. So VA is equal to 7.5, and summation Fy equal to 0, that is summation of force in the Y direction equal to 0. So this is X direction, this is Y direction. So from that we get VB is equal to 2.5. Okay, VB equal to 2.5, and then summation of moment, then no, okay, so take a summation Fx equal to 0, that is moment, that is summation of forces in the X direction. So you can get HA equal to HB. Okay, HA equal to HB, that is horizontal reaction at A equal to horizontal reaction at B. Why? Because no horizontal external force is there. Okay, now take moment about point C equal to 0. So okay, so it is the internal hinge, so it is a 3 hinge rod, moment about point C is 0. So take a, so HA into 5, that is the distance, minus VA into 0. So we have taken anti-clockwise positive, so HA into 5 minus VA into this distance 10 plus 10 into 5. Okay, so 10 into this distance 5. Okay, 10 into 5 0. So solving this equation we get HA equal to 5. Okay, so they can ask you to determine the value of HA, that is equal to 5, and VA you know equal to 7.5, and then HA, this is HA is equal to 5 kilonewton and VA is equal to 7.5 kilonewton, and it is in this direction, it is in this direction, it is in this direction. So what will be the resultant force? So R equal to root over of 5 square plus 7.5 square. Okay, so these kind of questions they can ask in the interview. Okay, so this is all about arch. Okay, so study this chapter also, they can ask questions from this, and advantages behavior under loading. Okay, so what we have studied so far. Okay, so what we have studied so far, so first of all, the BMD of portal frame, frame BMD of portal frame, and second is the cantilever bracket and its load transfer mechanism, cantilever bracket, and third is stress strain curve of ductile and brittle material, stress strain curve, and fourth one is the failure pattern of ductile and brittle material, pattern of ductile and brittle material, and fifth one is IS 13920, that is ductile detailing. Okay, and sixth is arch. So we had studied about the arch. Okay, so these are the things that we have studied in this video. Okay, so that's all for today, and thanks for watching this video. And if you find this video helpful, don't forget to share among your friends. Okay, so in our next video, that is in part 2 in of this interview question answer video series, we will discuss on some other important questions. Okay, so let's end our discussion here, and I wish you all the best. So have a nice day and goodbye.